Performance and analysis of Bagasse Ash for partial replacement of cement in concrete. Presented by S. Praveen Kumar, M. Kannan, P. Santosh Kumar, P. Egnavel. Guided by K. Riaz Ahmad, M.E. Abstract. Sugarcane bagasse ash is a fibrous waste product of the sugar refining industry along with ethanol vapor. This waste product is already causing a serious environmental pollution which calls for urgent ways of handling the waste. Bagasse ash mainly contains aluminum ion silica which is a personalic material. In this project, bagasse ash has been partially replaced in the ratio of 0%, 5%, 15%, 25%, and 30% by cement and concrete. Aim to study and investigate the compressive strength and split tensile strength of the concrete by partial replacement of cement by Bagasse Ash. Objective to reduce the cement consumption in concrete for the economic reason to control the environmental pollution. To find the optimum ratio of Bagasse Ash to cement. These are aim and objective. Need for study. The cement industry is the second largest CO2 emitting industry behind the power generation. It is found that each ton of the cement production produces approximately 1 ton of CO2 emission, which is 1 ton of important greenhouse gases as the global warming reason. Therefore, CO2 emission due to less cement consumption for the construction industries is used as a economic reason. Literature review. Chiang Mai J. Say 2013. Effects of fine bagasse ash and the workability and compressive strength of motor. The cement is the largest CO2 emitting industry behind the power generation. He described about the CO2 emission of which plays a global warming and environmental pollution. The areas of agriculture are approximately 41% of total land in Thailand. Agriculture products are mostly processed annually in the industrial plants such as sugar, rice farming. Therefore, he describes our Srinivasan experimental study on Bagasse ash in concrete. Ordinary Portland cement is recognized as a major construction material throughout the world. Researchers all over the world today are focusing on it by utilizing either industrial or agriculture waste as a raw material for the industries. The waste utilization not by economical, fly ash and silica fume are behind used as. Same way, the bagasse ash also can be used as it process personalic material properties. Ajay property and reactivity of sugarcane bagasse ash. Sugarcane bagasse ash, which is aluminous byproduct in the sugar mill when juice is extracted from the can. He also describes about the sugarcane bagasse ash can be used as uh, a replacement in cement and concrete. It attains a property by burning it at 500 degrees Celsius for 5 hours. Birku, Hailu and Adib Dinko. Application of sugar pan bagasse ash as a partial replacement of cement in cement material. Concrete is one of the most commonly used construction in the world. It is basically composed of three components: cement and water aggregates. He describes about the can be used as a in case of silica heat replacement bagasse can be used. Methodology: sample collection, material testing, and followed by cube casting, initial cube testing for mixed design, and then for testing mechanical property testing, split tensile and the hot tensile result, hot concrete test, and then we conclude the result analysis, and then last we conclude about the result. Then conclusion. Project duration. Aim and literature review in the January month and methodology and sampling material testing in the last January, along with February month. Experimentation started from the January second half and February and continues along with February fully. Result analysis along with the February and March, and book report along with the last end of March. Materials: cement 53 grade ordinary Portland cement, conforming to IS 12269 was used. The specific gravity of the cement was 3.15. Fine aggregate. Local river sand available at college campus, sand passing through 4.75 mm. ISSC was used. Fraction from 4.75 mm to less than 0.15 mm. The specific gravity of the sand was found as 2.58 and conforming to zone 2 of the table 4 of IS 383-1970. The image shows we have been taken through the scenario analysis of cement of cement Bagasse Ash in our college campus. This is our sieve analysis rotor machine. It contains various sieves of 4.75 mm, 4.75 micron millimeter, and then decreases gradually at 0.75 micron pan. This table shows the sieve analysis what we have get. The sieve size 4.15, 2.36, 1.18, 0.6, 0.3, 0.15 and less than 0.15. Weight retained 26 and percentage weight retained and cumulative percentage retained and percentage passing through it. Specific gravity of a fine aggregate table. We have made the trial 1, trial 2 and trial 3. From that we have concluded the average values. We have found out that the specific gravity of fine aggregate is 2.60 from taking over the average value. Coarse aggregate. The crushed aggregate used were 20 mm nominal size, maximum size, and are tested as per Indian standards, and results are within the permissible limit. The specific gravity of the coarse aggregate is 2.64. Specific gravity of coarse aggregate trial 1 and this also we have taken similar trial 1 and trial 2 trial 3. From that we have been concluded our average value. The average value of the specific gravity of coarse aggregate is 2.65. We have taken out in these tests. Bagasse Ash. One more time to repeat about to define about the Bagasse Ash. The Bagasse Ash sugar cane is collected in the vicinity of Sri Ambika sugar cane mill in Tukli, Tanjore district, Tamil Nadu. Sugarcane star ashes from the combustion of were obtained in electric furnace at constant temperature of 500 degrees Celsius for 4 hours. Once calcined, the ashes were grounded. The, the superplate in order to reduce the water content in the cement and to increase the workability of the cement, we have used superplate and complex SP430 disulfonate, naphthalene formaldehyde. The table 1 contains the composition of Bagasse ash, the components and their mass percentage. Major about silica, aluminum, FeO and calcine, which is the pozzolanic materials, is also found in cement. The images show about the Bagasse Ash, and Bagasse Ash has been taken weight on by our students. The image shows the Bagasse as a fine, clean, fine powder which can be replaced as a cement. Specific gravity of Bagasse Ash. We need how to find out the specific gravity of Bagasse Ash, so we have been taken out the test. As same as cement, trial 1 and trial 2, trial 3 have been taken out. From this we have found out that the average value of Bagasse Ash, specific gravity of average value, on 1.2. Mixed design for M30 concrete. Grade distillation M30 type of cement OPC 53 grade, maximum nominal size of aggregates 20 mm. Minimum cement content 320 kg, maximum water content 0.50 is taken. Workability 25 to 50 mm slump. Exposure moderate, degree of separation good. Test data for material. Cement used OPC 53 grade conforming to IS 8112. Specific gravity of cement 3.15. Specific gravity of coarse aggregate 2.64. Fine aggregate 2.58. Water absorption of coarse aggregate percentage is 0.6%. Fine aggregate 1.0%. C1 less is coarse aggregate conforming to table 2 IS 183 and fine aggregate 2 zone 2. Target strength for mixed proportioning FCK equal to FCK plus 1.65 S, where FCK target average compression strength at 28 days, FCK character strength compressive at 28 days. S is the standard deviation. From table 1 standard deviation S equal to 5 Newton by mm square. Selection of water cement ratio. From table 5 IS 456 to the maximum water cement ratio be taken as 0.50. Based on the experience around water cement is 0.45 as the cement is the 53 grade. Selection of water content. From table to maximum water content 186 liters. Estimated water cement 22 to 50 mm slump 186 liters. Add super blazes 25%. Proportion of volume of coarse aggregate and fine aggregate content. From table 3, volume of coarse aggregate corresponding to 20 mm, size aggregate and fine aggregate of zone 2 for water cement ratio of 0.5 equal to 0.60. Modify this as 0.40. The new values we get 0.63. Volume of fine aggregate controller as follows. Volume of concrete 1 meter cube. Mixed proportion for M30 design. Cement 413 kg per meter cube, water 139.51 meter cube. S. Fine aggregate of 6949.5 kg per meter cube. Coarse aggregate 1210.806 kg per meter cube. Water cement ratio 0.5. From this we have calculated the mix ratio is 1 is to 1, 1.6 is to 2.73. This is our M30 calculation mix ratio. The picture shows about the set apparatus for mixing. Before mixing, we have made we have to first mix the Bagasse ash and the cement first initially, and then cement, and then fine aggregate, and then coarse aggregate. Cube casting. From the above mixed design, the calculated amount of the material has been mixed as per the ratio calculated, and the workability of sample value and the slump value of 55 mm was obtained. The cube of 150 into 150 into 150 is filled by 3 layers of concrete and compacted periodically. The mold has been removed after the 24 hours. Weight cured. This is how the picture shows about the student has made the slump value test, which we have got the targeted strength as 50, and we have attained the target strength, target value. M30 concrete at 7 days compressive strength. Cube size 150 mm. Load 50,000 kilonewton. Compressed strength load by area 50000 by 22500, and we get the value compression strength 25.825 Newton by mm square. 63.73% has been obtained. The image shows the compressed strength for cement concrete for 0%, and we have attained the target strength from which we have calculated the mixed design. Compressed strength test for various percentage of Bagasse Ash as replacement in cement and concrete, and we have calculated and we have done through the all the replacement 5%, 10%, 15%, 20%, 25%, 30. Compressive strength of concrete, cement replacement percentage 0, 5, 10, 15, 20, 25, and 30, and along with the 7 days strength, 14 days strength, 28 days strength. The value shows the optimum percentage, the maximum percentage has been found out at the 5% replacement, and again the bar shows that the maximum percentage of strength we have attained at 5%. The graph shows the y-axis as a compressed strength Newton per square and x-axis as a Bagasse Ash replacement. It confirms that optimum percentage at 10% and at the maximum strength at 5%. Spread tensile strength value 0% replacement of Bagasse Ash 2.855 Newton per mm square, and at the 10% replacement of Bagasse Ash we have found that the 4.77 Newton per mm square. Result and conclusion. SBA in blended concrete had significantly higher compression strength tensile strength compared to that of concrete without SCBA. It is found that cement could be advantageously replaced with save up to maximum limit of 10%. This replacement result in similar concrete properties to that of controlled concrete. Higher replacement of percentage can be also used with a slight reduction in performance of concrete. The compressed strength result of the concrete have revealed that the concrete with 10% cement replacement by Bagasse has shown 5% compressive strength improvement at 20 days over the controlled concrete with 100% ordinary Portland cement. The 15% and 25% replacement has been shown that 3.4% and 12.2% reduction at 28 days of the concrete. Therefore, up to 10% is the maximum. There is no strength reduction. The workability of concrete also has been used. Thank you.